Hey, this is Steven from the Green Engineers. I want to go a little bit more into detail about the new addition to the Green Engineers team, which is the Dimension 1200 ES SST, which is a Stratasys 3D printer. So this 3D printer is going to be my workhorse for the near future until my own printer design is complete, and I'll be using that one mainly from that point on. And then this guy would go into some sort of backup position, right? Or maybe that, vice versa. Maybe one would be for production parts and one would be for customers' parts, just to make sure that, I make enough that I need to stay full time, right? And that's another big thing of what this guy is going to help with is the conversion between part time to full time quicker than normal. So let's go ahead and talk about this guy. This guy is about 265 pounds. It has a 10 by 10 by 12 build plate in it. It has a heated chamber. The chamber goes up to 80 Celsius. And it has two print heads. The two print heads go up to 300 each. So both of them go to 300C each, and it prints what they call SR30 support, which is sodium hydroxide dissolved support, and that's why it's an SST. SST is, I think, soluble support technology, I believe. And why it says 1200 ES is that is the cubic inches, right? 10 times 10 is 100, and then times 12, which is the height, is 1200. So that's why it says 1200 is 1200 cubic inches of build space, right? So that's why it's 1200. So, and again, when this guy is powered up, it pulls 1,000 watts to get up to 80C. It has a front, and this is an industrial printer, so it's got a lot of safeties on it. Backside has an actual breaker. It uses Ethernet for connection, and it has a DB9 connector for diagnostics for a diag port. In the backside, it actually has this giant PCB because it's actually a Linux computer. It's a full Linux computer on the back that controls this guy, and then it has some motion controllers that are actually integrated all into one PCB. It's got a very, very large PCB. Sorry about that, cat came in. And I don't know if you can see it, but basically back here, the board is about all the way up to this, comes all the way up into like here. So all the way from the bottom all the way up. Back here it has a filter that I need to replace, and then a breaker right there, as you can see, breaker switch. And then here's the Ethernet port and the power port. Sorry about that, it's my cat. She just came from underneath the garage door. Alright, so, yeah, 10 by 10 by 12. Amazing technology in this guy. It's starting up right now. You can see there. This guy was manufactured in 2007, 2008. So it's about, this is 2020, the end of 2020, so it's about 12 years old. But still kicks ass printing. So here you can see what it does for standby. It takes both nozzles up to, I believe, 100. It sits at 100, and then this guy will heat up until it hits 80C. And right now we are pulling only 92 watts. Okay, there it goes. It just started up. It's starting to pull more and more wattage. So it's initializing actually, so it's not even ready to start up. But we can open the door. And normally there's an electronic latch that holds this door closed, and obviously you can see it's magnetic, so there's a latch that comes in, holds this door closed during printing, but right now we can open it. As you see here, it's all insulated, foam insulated, and all this is, it's got a seal here, and you can see all the remnants from the last prints, and you can see here the seal all the way around. Seals against the front side of this door here. And then it's got dual pane glass for insulation. So there's a pane here and a pane on the other side. Yeah. Oh, and actually I could see the solenoid. The solenoid for the latch is right there. So yeah, it goes into this hole right here to keep it closed. So there's a solenoid for the latch. So inside we have some LED bars, one there, and that's controllable on and off. And then we have some 2 blower fans over there and 2 blower fans over there for 500 watt heater over here and a 500 watt heater over here. And here is the build table. Now underneath there's actually some giant gussets underneath that makes this table like super strong. Right, and then you can see the size of the rods here, which are now covered in stuff. So you can see the size of the rods and the size of the screw on this is very, very overkill for this size of printer, but that's perfect. And then up here you can see the heads and the size of the X and the Y linear rods, and then also up there you can see the power and the filament, the two filament tubes for the to feed the filament in. So that's on the drag chain. And so this guy actually has some very great technology. So if you could see here, that little bar is actually how it switches between the heads. So the 2 heads will actually rock in and out between which one is the current head, and in here you could see that they have the 2 filaments. One filament comes in this side, one filament comes in this side. And what it does is that actually rocks which one contacts that center idler, that center drive. So it only has one motor, and then what it will do is it will push each filament into that motor and will engage which one is actually being driven. So it will come with the head and actually push it against the wall or against this little tang. See that tang that's sticking down right there? It'll come with that bar and push it against that tang that's sticking down, and we'll change it to the other head. And then it will come back and press it against this other side, this other tang, and also change the filament back as well over there. And then on the bottom it will have a leveling probe, and then it will do the same thing. It'll come over and press a tang over on one of these sides. I can't remember if it's this side or that side. And it will pop it down, and then it will come and level the bed. And then over here you can see it's got a wiper assembly. So this is like some steel wire and a silicone flap on the back. And what happens is when it changes between materials, sometimes the material is sticking out a little bit, and you can see that I have some old material. This is some 5-year-old material, and it's very, very stringy, and it got crap all over the place inside the printer that now I need to clean up. So very stringy material here, but what happens is it'll let the filament drop a little bit when it's oozing a little bit, and then it'll come and clear it up on the flap. So theoretically it doesn't get stuck on your part, but with this material being so old, this yellow, I've had a lot of issues with that not happening, with it getting stuck everywhere and obviously falling everywhere. Between material switches, between the soluble support and the regular ABS. So, and then you can see it has its own tank here that actually holds all the junk in it. And you can just pop it out, and it has these 2 holes here, and allows you to come over here and dump all of the purge material to make sure that you are still printing nice and smooth. And then it's got a clear bar there so that you can see how much is in there. So really cool technology to have this purge tank, and it goes right behind the wiper assembly. So the wipers push the material into this box, and then the box, basically just lets it go. There we go, back in. So the basically the wiper assembly pushes the material in there and lets it fall in, right? And so that way you're able to, and you can see there's a hole there in the back that lets it fall in. Yeah, and then you can see it's got some various insulation all around to insulate it, and then it has vents right here. This is where the hot air comes out. As you see that it's got a vent here, right here, and a vent right here, which is right above the build table, right? And it blows air there, and I believe it also blows air. This might be an intake, but yeah, it blows air throughout this vent right here. This entire thing is a vent. So it blows hot air right above the nozzle and keeps the top of your print really hot. The table is not actually heated, it's passively heated by the chamber, so you don't have to worry about any electrical wires or anything like that. And then for end stops, it just has photo gate, one photo gate over there, and then I think another photo gate back there somewhere for the X, and then another photo gate for the Y. Pretty simple, and this thing has some pretty massive motors, got some big motors on it for movement and things like that, so pretty good. Actually, there's the end stop back there. And again, 1,000 watts to heat the chamber. And so what material does it print? It was designed specifically to do only P430, which is ABS material. And there you can see it's moving now. Actually, it's calibrating. Let me open the door. It latched the door. Well, the calibration is going to fail because the bed's not there. The bed's right here. So let's talk a little bit. So here's the bed, which is a pretty ingenious design. So I just did a big part. I'll show you here in a second. So as you can see here, what this is, if you look on the back, this is an ABS plate. And this is the same as the print volume here. This is 10 by 10, right? And then you print 12 tall. And then it has these individual little squares that you can reference off of the software to be able to tell where you printed multiple times. So as you can see here, what happens is it actually will embed itself into the material and get stuck because you're printing ABS and your bed is ABS, right? And you're printing at its melting temperature, you're printing at 300, right? So you're printing past ABS's glass transition temperature. So when you put down your first layer, it literally bonds pretty hard to the bed. So generally what you do is you do what you see here, is you print the soluble support as a raft, and then you start printing off of it, right? And then that way you can just pop your part off the soluble support, because it holds onto the soluble support pretty well, but if your print is tall enough, it's pretty easy to pop it off. And then actually the soluble support generally doesn't hold on crazy well to the part to begin with, to the bed, so usually you can just pop it off pretty easily. Now it would have been nice to have the tripod, but that's okay. So let's just show you guys here. So when you have this guy, it's pretty easy just to take it, and then you could just, okay, so there it just snapped off, right? And you can just toss this guy away. I'm not just hitting it, I'm just bumping it, and this support is so brittle that it doesn't really hold on crazy well. So you can just hit it a couple times and it pops off. And then clean all the rest of the junk off. There you go. Now it's ready to reuse. Now of course Stratasys, they say, hey, you can only use this, once, and then you got to replace it. But really, you can use it over and over and over again until your parts stop sticking. And then what you can do is you can just vary where you put it. And you can see here, it actually held on so well that you see some stress risers inside of the material, which is whenever you see white in plastic, it's because you have some serious stresses there. So it bonded way better than it should have in these spots. And again, the printer handles all of the leveling, right? So handles all the leveling, uses a probe, and I think it does like 6 points here, 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 and here. Don't know about here. It might do here. 7 points. So 1, 2, 3, 4, 5. I don't know if it does here. I think at least 5 points in each corner and here in the center. So at least 5 points for leveling, and then it does the bed matrix on there. But what happens is it has these hooks that you saw in the bed where this thing aligns, and then it has those two blue pieces that you turn to lock these in, and it aligns itself so well inside of the chamber that I can actually pause the print, pull the part out, inspect the part, look at how the part's doing so far, put it back in, and allow it to, and it won't have any sort of start and stop line. It'll all be seamless, right? I couldn't see any start and stop line. So really, really, really good. So very great design here. Obviously, if you ever damage one, which very unlikely to do so. I've done maybe 10 prints since I've had this machine. Got it last weekend, Sunday. Today's Saturday, so I haven't had it for about a week. Haven't damaged it yet, but I have the previous owner that I bought it from gave me 15 of these guys, not including this one. So I have enough for probably most of the life that I'm going to have of the printer, right? So I just keep putting this guy in, keep printing on it until this material is pretty much destroyed. You can see it is textured. That's why you got that matte finish. It does have this texture. But overall, ingenious design, these plates. Great job, Stratasys. Obviously, Stratasys, they've been printing for 30 years before people even knew about printing, right? About 15 years ago or whatever. And again, this machine's 12 years old. They already knew about bed leveling. They already had a very good bed material for their particular material. They already knew that they needed heated enclosure, which they had the patent on. That's why nobody else did it for a really long time. And all of these things, right? So they already knew about all that stuff, and that you need to index it to allow you be able to pull it out. They had a print queue already enabled, so where you could put multiple prints in a queue and not have to be there to send the next one. So you just have to pull the piece out and put it in, and it will run the next part in the queue. It'll bring up the next part in the queue, and you could do actual prototype production work, because again, that's what this was designed for, prototype production work. But you could also do it for production work, right? And another trick that you can do with Soluble Supports, if you don't know, to be able to increase the amount of production to be almost capable of the belt 3D printers that you may be familiar with, is you could print a part on here, right? Let's say this part here. You could print a part on here, and then you could put some supports on top, and then print another one on top of it. Put some supports, print another one. So you could run multiple spools of filament through this guy on one part, right? And to run through 1 kilo of filament on this guy, I just did this part that I'll show you in a second. It took about 30 hours, so you would have to replace the material every 30 hours, right? So you could have the material stack up and print, a whole bunch of those, or even something like this, right? You could do, well, it's a little bit more than a square. Ideally, you would have 1 square, because this is you have 1, 2, 3, 4, 5. So each of these are 2 inches, right? So this is your 10-inch, and then 5 this way, and they're 10-inch. So it would be perfect if you have a 2x2 part, and then you could do 25, and then stack them on top of each other. And then if they're 2 inches tall or 3 inches tall, I think this is like 3 inches tall, then you could do 4 of these on top of each other. So altogether you have 100 of these parts at a time. You could print 100 of these parts at a time. If it was 2x2, in this case it's not, so it'd be a little bit harder to do. Anyways, so and then obviously you have the capability of supports, dissolvable supports, which I've never been able to do before. This is what's preloaded inside of the printer itself. That's why it says Dimension right here, which is the brand name. And actually, I believe this was an independent company, and then Stratasys bought them out, and now they're Stratasys. Anyways. Or they might be, they might also just be a division of Stratasys. So if you can see here, this was assembled all one piece, and now as you can see, it works. So basically it printed supports in between these teeth. It printed supports to hold up this guy, and then you put it inside of a tank that the previous owner gave to me, which is a sodium hydroxide tank, so NaOH. Tank, and that will dissolve away the supports but leave the ABS unaffected. And so this guy's stock has 2 layer heights. It has 10 thousandths, which is kind of a weird number, but it's about 0.21 millimeter, which is basically the standard for 3D printing as far as strength and time is concerned, as well as resolution. If you go any kind of lower, then you kind of waste a lot of time. That's why it's one of the ones that they picked. And then 13 thousandths, which is like 30.31 or 0.32 millimeters or something like that. So those are very common. One's higher speed, right? And 0.32 is usually 80% of the nozzle diameter is as thick as you want to do it, right? As you want to do a layer. And they knew that 12 years ago, right? To where they would set it up. So that is what this guy uses, a 0.4 nozzle on both supports and material. So you're able to do some cool stuff. Now, one of the things, like I said, is that I'm trying to figure out is the seams. As you can see on this one, it's got a very, very nasty seam. Seam is where, when you're doing a contour or an outside, in this printer it calls it a contour. When you're doing a shell, right, different programs call them different things. So shell or outline or outer wall or a wall, right, etc. So basically, when it's doing the outside wall and then the infill, it calls a raster. And this printer calls it Stratasys. They call it raster. So then you have the raster, which is the infill. And so the outline, in this case, is when you have, or a contour, sorry, is when you have a start and a stop. So it starts here, and then the head goes around, and then it ends back on this point. So that's why you have this line. That's where the start and stop points are lining up all the way across. And you can see it a little bit more in this guy. So there is a hack that you can do on this printer. There is a newer version of this printer, which is called the Fortis 250 MC, which is Stratasys kind of production grade guy. More expensive than this guy. So right now you get these used anywhere between $5,000 and lower, or anywhere between $2,000 to $7,000 depending on your location. Those guys usually are 10 to 15. The funny thing is it's basically the same exact body. It's got a little bit of different color. Instead of gray, it's more of a dark gray, and not much else. It's pretty much the same exact printer. But Stratasys shipped it with way more features as far as software support, and also the smaller layer height. You can do 0.007, which is like 0.14 or something millimeters, right? Around the 0.1 area. So you could do like a really tight, like model work or whatever. For mechanical, 0.2 is really good, but for models and stuff like that, where it's a organic shape like a person or a statue or something that you're gonna paint, 0.1 is pretty good. So they had some software called the Insight software, which is kind of Stratasys more customizable. With this, they shipped what's called Catalyst EX, which was a very basic program. You could barely control how the supports work. You can't really control how the infill works. You can't really control how the seam works, etc. Insight, which was only supposed to be capable of providing support for the Fortis 250 MC, which is the lowest version of the Fortis series, which again is just a small, I think, just software upgrade. I don't know, even hardware upgrade of this guy. But they use Insight software, which allows you to control the seam, allows you to control how many contours you have, which you couldn't do in the other software, or how many shells you have. You have 2, 3, 4 single shell, etc. What angle the infill is, or the raster they call it in this. What's the angle of overhang at the point when it adds supports, all that kind of stuff, right? So it had all that capability, which it didn't have before, right? With the Catalyst. Even now they have the GrabCAD print. So Stratasys apparently owns GrabCAD or whatever. So they had the GrabCAD print, which also has locked out features for this guy that you can't get on the Insight software, which is the Fortis 250 MC, which is a slightly upgraded version of this one. But there is a hack that if you use the 10.6 software, you can grab the models, which they call a modeler, is the profile that slices for this guy. It's basically like a slicer profile, and you could just copy and paste them into Insight 10.6. So as long as you can find a place to download Insight 10.6, and they're all around, the version 10.6, then you just copy the modelers and paste it inside the 10.6 version. There you go. Now you can actually use Insight with this printer, and now this printer is just as good as the Fortis. And then even if you wanted the 0.007 thousandths layer heights, 0.1 whatever millimeter, then you could actually just change the modeler's notepad and get that 0.007, right, if you wanted to. So now basically this has all the capabilities of that, $12,000 printer, right? So, and one of those is to randomize the seams. So as you can see here, this one is picking randomly where to choose where the seam goes. And now what I'm led to believe, I've been getting a lot of help from a guy on Reddit. He's saying that he believes that usually when he has this issue, it's because the filament is moist. And again, this filament is about 5 years old, right? So he thinks that if I run new filament, this would be fine. So we're going to see if that's the case, because I have some new filament coming in here soon anyways. Yeah, so this is this guy. Let's go ahead and talk about the material. So that's the software. If you get the Insight to work, is highly recommended because you have all of the customization that you want to do. Also, there's Maraca EX, which is obviously Catalyst EX, Maraca EX, is you go in and actually change some of the temperature settings on this guy. So the extruder or the enclosure is a different temperature, right? So let's go ahead and talk about the material. The material is stored in these cassettes, which is pretty nice. So actually inside of these cassettes here, it's two pieces. There's a O-ring on the inside that actually will seal this from the outside air, right, mostly. And then on these, they're actually chipped. So this is where a big backlash against Stratasys has come from, because Stratasys, they require that you buy their material. And for example, this guy, which is 56 cubic inches, which is basically 922 cc's, which is pretty much 1 kilogram, right? So this material is pretty much 1 kilogram. Is $272 for a commercial, and then like $130 for for education. So very, very expensive compared to your $30 a kilogram for other material, right? And mainly that was because you couldn't run it because you would need this chip. And this chip will tell the printer what color it is and what settings to use, also how much material is left. When this chip hits 0, it will no longer let you feed in material. But now, since the printer's been around for a long time, people have figured out how to use a two-wire communication and tap into these two contacts and basically rewrite the EEPROM on this chip to refill it. And so now you can put in any sort of generic material in here. And also some companies have reverse engineered the chip, and they actually provide the chip with their product. So what happens is you take these 4 screws out. 1, 2, 3, 4. Take these 4 screws out, you take the filament out, the old filament out, you drop the new one in, you slide in your new EEPROM, and now you're good to go with brand new material. So there are some companies that sell their material anywhere between $90 and $105, and then now while you're kind of buying that is that Stratus had another proprietary thing that they did to kind of grab a hold of the market for replacing the filament, because I'm sure that they knew eventually someone was going to reverse engineer it and figure it out, because there's a lot of smart people around there that don't work for Stratasys, right? Is that they make the filament's actually 1.770 millimeter, not 1.75. So it's actually 70 thousandths instead of the 1.770 and 1.750 millimeters. So if you extrude your own material, you're going to be 0.020 millimeters under, and what you'll have is you'll have some slight under extrusion if you use regular 3D printer filament. Now these other manufacturers, these aftermarket, they call them generic manufacturers, they make their filament 2-spec to 1.770. So that way you don't have any under extrusion issues. So basically right now I'm cleaning out some of this material to free up the cassette to put in more material in here. If you can see here, this guy was manufactured in 2017. And then the yellow, which is what I showed you on that cup, is manufactured in 2015, so it's 5 years old. And so I just blew through my yellow by printing this, which is for one of my courses. This is an automatic refilling cup concept. And you could see here, basically it has these heat sinks. And in between the heat sinks, it has all of this water-soluble support, sodium hydroxide support, which is the SR30, which is a Stratasys product. Right? And so with this tank, I got a very large tank from the previous owner. And it boils it takes 11 gallons of water, and then you pour in like 3/4 of the Waterworks sodium hydroxide material. Right, so here is the Waterworks sodium hydroxide material, as you see, Stratasys, right? And then they come in for $140. You get 12 of these, and these will treat an entire load of that water until it basically evaporates on you. So yeah, you just mix this guy in, and it's for the P400, which is the standard support that comes in this guy. Anyways, so yeah, you load it in there, and then that guy's an ultrasonic tank, so you heat it up to 60°C, hit the ultrasonic, put the cover on it, wait a couple hours, and all that support is going to be gone. So this is the first printer that I have that is capable of doing soluble supports. So as you see, I did a pretty big test. This almost knocked out the entire rest of the spool. The spool was 70%, so you could say 700 grams, 720 grams left. And I basically knocked out the entire rest of the spool. This weighs about 2 pounds. And the rest of the model spool, they call this the model material. The yellow is the model material, and then this is a soluble support material. They call it support material. So these have just fins, and in order to hold the fins up, they put support material in between, because there's nothing in between these heatsink fins. And then as you can see, the surface finish of this is not very good. This is the first print I've done with the 0.13 thousandths, 13 thousandths layers. The rest of them I've done with 10 thousandths, and as you see, you can get really, really good surface quality with the 10 thousandths. Very, very impressed with that. Anyways, so, and you could see all the moisture in this, all the popping and stuff like that. Luckily, because this printer is so oversized for what it needs to be, I could throw material inside the left and right cheeks of the printer, to the left and the right of the build plate, and then I could 3D print some holders. And this guy heats up to 80°C, which is very similar to what you would have to use to dry ABS, which this guy prints. This material is supposed to exclusively print in ABS, but you could also print in ABS or ASA or anything that prints at a similar temperature. Obviously, you cannot change your retracts and things like that, so it's really trial and error. You could try different materials, but most of these generic printing companies that make material, they'll make ASA or ABS. ASA is similar to ABS except for more UV resistance, so it's better for outside applications. So, yeah, so what I'll probably do is maybe dry the rest of this material so I can actually use it for projects. And this is again this is actual Stratasys stuff. So originally this would have cost $260 almost right here. This is probably $200 worth of material, right? And so I could take the spools out of the cartridges and put it inside of the printer, and then have it during this print like this for 30 hours. I could have it dry the material for no extra electricity, right? I'm already gonna run it for 30 hours, and it's just going to evaporate it out, and then the moisture will leak out the seams. So yeah, and that's why I'm getting this really, really not so great surface quality, is because all the bubbles and stuff that are present in there, and all the moisture, because again it's been sitting, and even though it's inside of this cartridge, it's going to get in through the O-ring at some point. There's always a leak through O-ring, and again, this plastic on plastic, so you're going to have a leak, and eventually the moisture will get in there. Most of the time, for ABS, it's a good idea to use it within a year. Otherwise, dry it, or you may have some. They only guarantee performance within a year. So I'll get some. I have some more ABS coming for a project that you see these are for, which is for escape room stuff. And Also for other projects, for example, I'm going to be printing some stuff for the shredder and some stuff for all the prototyping for the Factory, which is my V2 of my extruder, and also for my 3D printer design. I will also do that as well. So that's basically the rundown of this printer. Really cool printer. I'm really excited to keep using it. Really good. I have obviously a couple more some setup to go with the material and how to get the material dry and get some new material into it. Also, I have the EEPROM reader coming in, reader and writer, so I can rewrite the EEPROM to refill it to put in some generic stuff. So for my personal projects, I'll probably use regular material with the 1.75, and then for customer projects, I'll use the generic stuff. Or if the color is not supported by the generics, for example, I'm going to be doing some clear. The generics, they don't even sell clear or glow in the dark, so I'll be using that here. And I have a whole bunch of extra parts for this guy, so I have some extra nozzles and some liquefier tubes and some wiper modules and some fans, and then also the cooling duct for the cooling fans, part cooling fans. Alright, so that is basically it for pretty much all I want to talk about. And again, you attach it here. You could attach it through Ethernet, or in this case, have a crossover cable to be able to plug one PC into the PC that's in here. That's the only way to attach two PCs together with one wire, is to use a crossover cable. And then otherwise, you could attach this to a network and even remote in from another location and be able to run this printer. Alright, so it takes about an hour to heat up, so we'll heat up, maybe do some more printing. I have the tank heating up in the backyard for this guy, so we can go ahead and toss this guy in and see what we have happen. Alright, so that's basically it. I wanted to talk, and I plan on doing this a lot for a lot of different machines that I get to talk about kind of if you would possibly want one and stuff like that. And also, I don't see any reviews or anybody talking about this guy on the internet for whatever reason. I don't know if Stratasys gives out, you know, DMCAs or strikes or whatever on YouTube or whatever. So I don't know why there is no reviews. There's just people talking about them, but I never see people say, okay, I like this or I like this. This is what I'm dealing with right now. This is what I did. Blah blah blah, etc. Right? Anyways, so that's it for now. I do plan on getting some other Stratasys machines. We'll be talking about that at a later time. But so far, so good. I would give the printer about, at the current state, 7 out of 10. If I get that seam gone, I would give it probably a high 8 or 9 out of 10. Obviously, get some knocks for, you know, the proprietary filament diameter and stuff like that. But other than that, that's probably where it lost that 1 point from going from 9 to 10, is to pay extra for the material. Anyways, so, but this ABS is superior. The Stratasys ABS is superior to pretty much all other ABSs. It is stronger and more tough, as they paid for a lot of chemists to modify the ABS chemistry to get some extra material out of that. Most of the strength comes from the heated chamber, and that you have each layer is fully bonded. Alright, that's it. I'll probably talk more about this guy later on, but that's it. Yeah. And for the cassettes, you just press the cassettes in, and it'll suck the material in for you. So the top here is model, this is model, and this is support here. Alright, so that's it, and I'll see you guys on the next one. Take it easy. Peace.